Alright, today we're going to talk about forces, balanced and unbalanced. So our essential question is, how do forces affect motion? So please write that at the top of your notes there. Okay. This is PS10. We're going to be talking about Newton's laws for the next section of our unit on force and motion. Alright, so what I have here is a couple cars, right, and we're going to talk about the next section, which is, what is force, how does it act on an object? Okay. And the first thing you need to know is what force is. And force is a push or a pull. So these two cars, coming back to them, if I'm pushing it, I'm putting a force on it to cause it to move to the right or move forward. This one, I'm still using a force. There's a force to push the car on this side, and there's a force to push the car on the other side. So one's going right, one's going left. And the car's going to stay still if the forces are the same. So a force causes anything to move. Okay? So all forces are vectors, which are they have size and directions, and we always use arrows for vectors to show the size and the direction of any force. And then finally, the unit we use is called the newtons. So force is expressed in newtons. Forces do not always cause motion, though. So at the top here, I could show you how force, something pushing on a car. If there's no forces on one side and there's a force on the other side, it's going to cause the car to move. But if you have two forces and if they're equal, it's kind of going to stay still. So here we go. Our next section is, what is force and how does it act on an object? Okay. So on your notes, okay, we're going to talk about forces that can act on objects. And one is a contact force. And the contact force is, take a look at this bike, is kind of like the frictional force. Okay? We've all experienced friction before. So if you have a bike, right, if it wasn't for friction, you wouldn't be able to go. So if you take a look here, the contact force is the tires that are on the road. And as the tires meet the road, that frictional force going this way causes the bike to move forward. If you've driven your bike on snow before, you've probably realized that, like, your tires will slip, you don't have much friction, so you can't go as fast or can't go as well, and maybe you even fell off the bike before. Okay. So cars, tires, or any type of tire relies on friction. Even your shoes rely on friction. Okay, if it wasn't for friction, you wouldn't be able to walk down the hall. And the cars may slide off an icy road because it lowers the force of friction on the tires. So that contact force, or the friction, is lowered if it's icy, or if we use oil or some type of lubricant like WD-40 in our cars to keep the gears and the different wheels moving. Another type of force is gravity and magnetic force. So let's talk about those. First, forces can act on objects that are at a distance. Okay? Even with the sun being so far away, it's acting on you, me, and everything else. Okay? It's the reason why the Earth continues to orbit or revolve around the sun. So gravity is a force that pulls an object towards Earth. Now, the farther you are away from Earth, the less gravity affects on you, right? Because if you go up in a space shuttle, you don't really have any gravity once you get so far up. Okay? So the force of gravity gets less and less and less. The moon has gravity, and it affects even our oceans from 275,000 miles away. So we have tides, which are caused by the force of gravity as well. So magnetic force is another one. So if you ever had like a magnet and then you try to you can hold like a piece of paper or something on a refrigerator, okay, because the magnetic force pulls towards the metal, and so when it has like poles, two magnets will push apart. Opposite poles, two magnets can, attract. And so here's a little example of like a magnet, okay, and there's a paper clip is getting attracted to the magnet, even though, okay, it's not touching the magnet up here, it's just being attracted to it. Okay. All right. So let's get on to the other side of your paper, and the other side says, what happens when multiple forces act on an object? So now we're going to dive into newtons and how we can actually diagram forces balanced and unbalanced. Okay. So the net force is a combination of all forces that act on an object. So I have a couple examples here on the screen. Okay, so we have a net force of 20 newtons pushing this way on the book, and a net force of 20 newtons pushing this way on the book, And the net force is 0 newtons, okay, because 20 going one way and 20 going the other way, they're going opposites, so they kind of cancel each other out. Okay? So when forces act in the same direction, they're going to be added to determine the force. So here's an example right here. Okay? So I have 8 newtons plus 6 newtons, and the force is 14 newtons. The net force is 14 newtons going this way. Okay? Because they're both going in the same direction, and they're going to push the book. Okay? The other one is when forces act in opposite directions, and the smaller force is going to be subtracted from the larger force. So I have a tug of war, and tug of war is a great example. So we have these two teams pulling on a rope. Okay? If you ever played tug of war, it's whoever has the most force wins. So this side, on the left side, they have 320 newtons of force, but on the right side, they're pulling with 300 newtons of force. Well, the net force, if I take 320 minus 300 newtons, you get 20 newtons, and the side that has more newtons is going to go 20 newtons to the left, because they have more force. So they may not go very fast to the left, but they're going to be pulling that rope and everybody over to the left. Okay, so that is what we do with opposite directions when it comes to force. So net force is just the total amount of force in a system or in an object that's being applied to it. You can have 0, a net force is 0, which means it's not moving. You can have a positive net force going in the same direction, which is like here 14 newtons, which means it will be moving. And then if you have it in opposite directions, you have to subtract the two sides and figure out who has more force. Okay. So continuing with that, so a net force of 0 means that the forces are balanced, and that's the key word here, they're balanced. They're not going to move. We call it balanced forces. And it will not cause change in motion. Okay. Unbalanced forces produce a change in an object's motion. Okay. And the object could change speed, direction, or both, okay, if it's unbalanced. So this change is called acceleration. We talked about acceleration earlier. So anytime you've seen a change in motion, it's called an acceleration. So acceleration always is in the direction of the net force. So we have up here, this is kind of like a net force of 0. Car stands still because one person's pushing one side, person's pushing on the other side, and it's not moving. Down here is the same example. Truck, 100 newtons. Now I put a little vector here. This little arrow is a vector. It's 100 newtons on this side. You have 100 newtons over here, and so it's a balanced force. The truck's going to stay still. However, down here, this is an unbalanced force. So we have 100 newtons pushing, and you have 60 newtons pushing over here. So it's going to move in to the direction of the right because it's a larger force going to the right. Okay? And that's accelerating. Okay? That's what we call acceleration. Right? A change in velocity. Okay? Right. So here's some examples I like. Just to kind of recap. Okay? So 5 newtons pushing to the right, 5 newtons pushing to the left is 0. Forces can cancel each other out and produce no net force. So football players on like a line of scrimmage is an excellent example of that. Okay. Gravity is a good example. Hey, you're standing on the earth and you're pushing down on the earth, but the earth's also pushing up on you. And if you're just sitting there or standing there, your net force is 0. Okay. All right. So here's some more examples. So forces, like we said, may cancel each other out and produce no acceleration. Okay. So there we go. There's that example. Okay, push, maybe if you're pushing a door, okay, doing tug of war like we talked about. Okay, so if the tug of war is even, you're not going to be going anywhere. Okay, all right, but you could also have unbalanced forces. And unbalanced forces, if the multiple forces acting on at one time are not balanced or equal, then acceleration will actually occur and the object's going to move. Okay, so it's kind of like having this little scale. Okay, you have, if it's balanced, no motion, but if it's unbalanced, there's going to be some motion. Okay, and like kicking the ball will cause something to move quickly because you'll have an unbalanced force. Okay. Okay. So here's a good example there of unbalanced forces. So if I have 5 newtons pushing and another 5 newtons pushing on any object, okay, what you're going to have is you're going to notice all the forces are pointed in the same direction, so they're going to add together. Instead of only having 5 newtons, I now have 10 newtons. Okay, and it's going to push. Okay, that's like you pushing a box. You and a friend pushing a box, and your net force will be added together to make the box move. Okay. Okay. Here's a car. If you try and do it all by yourself, you might not be able to do it. But if you have extra people, okay, and you put more force on it, your net force will increase, and you might be able to push your car if your friend's car is broke. Okay. So unbalanced forces, here's again, we can actually, if we have a force 2 here, we add them up, and we have a force pushing in the opposite direction, we got to find the difference. So we have to subtract those forces. We know it's 10 over here, and it's 5 over here, so there's going to be 5 more newtons, a net force of 5 newtons pushing to the right. Okay? All right. So notice that the forces are unequal, and they point in the opposite direction, so they're going to be unbalanced and work against each other, or one partially cancels out the other. Okay. All right. So this is like someone down here pushing that bookshelf. If you're pushing one side and someone else is pushing the other side, and you really can't get anything to move, okay? Or whoever's stronger might move it. The end result is that the forces on the left are slowed down by the single force on the right. That's the end result up here. Okay. All right. So once again, what happens when multiple forces act on an object? We're going to take a look at this picture here. Okay, so we have a couple different forces here. We have this guy pushing over here. You have gravity pulling down. Okay, so let's get a little pen here and show you. Okay. He's pushing this way, and you have gravity pulling down. Okay, and so if the gravity or the frictional force isn't as strong as him, then he will make that box move to the right. Okay. If frictional force is stronger, then will he be able to move it? Probably not. Okay, it'll be a balanced force at that point. Okay. All right, so let's take a look at the last one. So we already talked about what forces are acting on this box, okay, and how we can determine if forces are balanced or unbalanced. If it's moving, it's unbalanced. If it's not moving, it's balanced. Okay. Right. When you arrive, you're going to be doing this core lab here, and here's a little preview of it. So you can read through it if you would like, and then be ready to do the lab. We'll discuss our notes when we come in and do our station labs. See you then.